Hey, hello everyone. Thanks for joining in. So I'm going to talk about building an offline first web app with RxDB and Hasura. A little bit of introduction about myself. I'm Praveen, developer advocate at Hasura, which is Hasura basically gives you GraphQL APIs by connecting to different data sources. And I'm a full stack developer. I worked across a bunch of technologies, starting from jQuery days, and then I've moved to React transition. And on the backend side, I've moved from Django to like a Node.js stack of late. And of course, for packaging and deploying stuff, there's Docker. Right. So today, I'm going to talk about building an offline first app with RxDB and Postgres. And we're going to make use of RxDB for local storage of data, and RxDB stands for like reactive database, and it's a NoSQL data store on the client, and it gives you like a replication layer with CouchDB or GraphQL, right? And that's one of the reasons why we're using RxDB here, because of the GraphQL replication layer, and because of that, we'll be able to use databases like Postgres via Hasura GraphQL, right? So Hasura gives you GraphQL APIs by connecting to different databases, including Postgres, and you have like a real-time API with authentication, unauthorization, configurable, right? And with this setup and with this set of tooling, what we're going to do is we're going to create like a front-end app which will make use of RxDB on the client, and it will make use of GraphQL replication layer of RxDB to be able to sync data with Postgres, and make use of Postgres' feature on the backend, and also use like an offline first app on the front end, right? So the architecture will typically look like this. We have like a backend service, and there are like a couple of devices which are present, which is like one would be a local database on the device one with an application, and there's another device two with another local database and application, right? So each individual device or a session will have its own local database created and set up, and the application will be connected to the local database for data syncing and data fetching, right? And the backend service would be the interface for both of these devices, and the local databases will communicate with the backend service to fetch data and to keep the application in sync, right? And in this case, the backend service would be Hasura GraphQL, and the local database will be created by RxDB, and it will be a NoSQL DB store, and the application is a React app, and we can technically replace it with any front-end app, right? But this is how the stack architecture is going to look like for this demo. And when I meant offline first, what does it take to create a truly offline first app, right? The code and assets are offline. The data which changes on the client are locally done first and then synced with the backend service, right? And when it's done locally first, it also comes with an added benefit of optimistic updates. So what is an optimistic update? So when you make a change on the front end, there is a latency for the UI to show the results that's being updated, right? So let's say you're entering an input and you want that input to be displayed on a UI. There is a latency that's involved because of the fetch request that goes to the server. The server does some processing, stores some data, returns some ID, and you want to ensure that the request was successful, and then you show the data on the front end. And this latency will cause a slightly bad user experience for the user. And what we're trying to do with optimistic update is that we always assume that the request is successful, and we make sure that the UI is updated instantly as soon as the input is given. And so this is basically a state update on the front end, which is an instant update. And the asynchronous request goes in the background. It takes its own time to update in the server and then returns back the response. Most cases, we would want the request to be successful, and we assume that that will be the case, and hence we stick to the optimistic update. And in case something goes wrong on the server and we want to do something else on the client, we roll back the change that we did on the front end, which is basically rolling back the state update that we did to show the input data on the UI. Right. So doing changes locally first has this added benefit of optimistic updates, where the user experience is a lot better. Instantly the updates are being shown on the UI, right? And obviously, once the optimistic update is ensured, the user experience is better. Once the request is successful and you get back the response from the server, we can now sync it back to the cloud for whatever offline data that was there previously, right? So the idea is to keep data locally and then sync data to the cloud later, right? So on the same notion of local first and cloud later, what are the tools that are being used in this demo, right? We have RxDB for a local first setup, and we have Hasura with Postgres for the cloud setup. So Hasura gives you GraphQL with multiple databases. In this example, we're using Postgres, but technically this could work with MySQL or SQL Server, or any other database that Hasura supports, and wherever mutations are supported by Hasura, right? And RxDB gives a pretty good setup on the front end for automatically taking care of a bunch of things. So we'll look at what are the different things that RxDB takes care of. So RxDB has a GraphQL replication layer, and that lets you sync it with the GraphQL endpoint. And you start off by like defining a schema in RxDB store. You initialize the data store locally. It will create a NoSQL store, and then you also like define a schema. So let's say we are creating like a to-do app. We have the ID, the title of the to-do, and the created timestamps, and the user who created it, right? So we have a bunch of these fields that needs to be created. We'll define the schema, and RxDB has given a spec for that. And we'll use that schema to define the models. So it's basically data models being defined on the client. So you've defined a structure for the schema. You've initiated the data store on the client, and then we have a couple of things to do, which is basically to fetch and also like dispatch data. So the fetching bit can be done through pull query, which is a function that RxDB exposes for you to basically make data sync with the server. So the pull query will actually make a call to the server and then get the data and then store it locally. And any more changes that you do on the client will actually reflect, can be reflected later whenever there is an offline sync that needs to happen. And for push query, that is when it will be triggered when the offline mode is now switched back to online mode. You want to now push data back into the client, into the server, right? So you have a couple of methods to write on. So you define the schema, you write a pull query, and then you write a push query, and these could be GraphQL queries and GraphQL mutations, right? So pull query would be a query, a GraphQL query which fetches to-do data, and push query would be a mutation which would insert to-do data, right? So let's look at the demo quickly. I'm going to show you the code part of the demo to start with. I have this RxDB React app on my machine. So the structure looks pretty simple. It's a React app with an index.js. There's a to-do component structure, and there is an app wrapper and app.js and stuff, right? The first bit for enabling an offline first app is to register a service worker. So we have the default configuration for service worker defined over here, and in our index.js we have enabled the service worker.register line, right? So this is all pretty basic stuff. And when we come to the database bit, this is where things get interesting. So we have a bunch of modules being imported from RxDB. They have plugins to validate, to check error messages, and obviously we talked about the replication GraphQL plugin, right? So what we're going to do is, so we've initialized RxDB. So if you look at these lines, so this is basically initializing the RxDB client and creating a data store on the front end. It's using an adapter, and it's using like a name for the database, which is TodoDB, and we're awaiting a collection of a schema. So to initialize the database, we need to give the data models that are required for the DB, right? So we'll have to define something called a schema, which in this case is a to-do schema, which is being imported from the schema file. As I mentioned before, the schema has a structure. So this is, for example, this is the to-do schema, which has like the properties like the ID, text, with the to-do is completed, and the timestamp data for created that and updated that, right? And finally, it will have the user who created the to-do in the first place. So there are some required fields, some are nullable fields, and so on. So you declare all of this schema, you declare the versions around it. So if another field changes in the future, you can update the version number over here, and then the syncing will happen automatically in the next deployment, right? So we've created the database. We have also defined the schema that is there for this particular example. We now need to define a couple of methods, which is the pull query builder and the push query builder, and we have this GraphQL replicator. So RxDB exposes this GraphQL replication plugin that we have imported from the RxDB plugin. So we're going to make use of this RxDB replication GraphQL to initialize the GraphQL setup. And Hasura also supports authentication with Auth0, and that will be implemented using an auth token. So we have like an Auth0 setup connected to this Hasura instance, and we have a token that can be sent for the authentication bit, right? So this is the initial sync GraphQL setup for the replication stuff. So we have the to-dos DB schema that's being synced. The sync URL will be the GraphQL endpoint. In this case, this is currently hosted on a Heroku app, and we can host it on wherever Hasura can be hosted. This could be Hasura Cloud or your local endpoint for testing, right? And there's a headers that we pass in for the GraphQL endpoint, because this particular endpoint is now secured with Auth0. So you need to send the auth token as well, right? And for the push and pull, we write the pull query builder and the push query builder, whatever, to ensure that the right queries and mutations are being called whenever there is a change, right? And we've enabled live to being true, so that there is a polling that happens in the background as a subscription, so that data is in sync pretty regularly, right? Otherwise, you need the user action on the front end to be able to trigger a live response, right? So since we've configured live as true, we'll also set up a WebSocket client for this to work. So here we have set up like a HTTP client, which is the sync URL from the GraphQL endpoint. And for the live sync, we will also use the WebSocket connection, which would be WSS endpoint of the same GraphQL URL. So we create a new subscription client, passing in the same authorization headers with a timeout and stuff, right? So, this is the subscription query that's being called and it's being sent to the Hasura instance. So we're getting data for the to-dos table, which has the ID, deleted, is completed, and text. So, right. So let's look at the pull query and push query specifically. So for fetching data, we need to now make a query to the to-dos table, and Hasura gives you a way to query all of these tables automatically because of the API is being generated. And we'll quickly look at that on the backend part of it. So this is the to-dos GraphQL query. There is a where condition that's being written. We're checking the updated at timestamp being greater than the current time and whatnot, and the ID being greater than the current ID that's already there on the local DB. We're limiting by a batch size, which is 5 by default that we've defined, and we're ordering it by the timestamp also, right? And we're also fetching a bunch of these fields that we've declared in the schema. So this is the query that we have defined for fetching data, and this is going to be made against the GraphQL endpoint that we have given earlier. And for the same similar method, this is for the push query, which would be to insert data into the DB whenever there is a change that happens. And we'll look at that in the actual UI demo and what's happening. So this is the mutation. This would be the insert to do. So this is also an auto-generated API that Hasura gives you for inserting data into the DB. And we're sending an object, which is the $to-do, and that will be sent as a variable for this GraphQL mutation. And we're returning back the ID once the to-do gets inserted, and then we can store it in the local DB and then render it on the UI, right? So we have this push query and pull query builders written. So this is just two GraphQL queries that are being written. Technically, this could be any GraphQL query, meaning this is currently now hitting Postgres with Hasura, but Hasura can also expose other GraphQL queries with other data sources and other DBs. So this could just not be restricted to Postgres, but it could be any other data source to make it offline first, right? And finally, on the authentication bit, since this is now protected behind Auth0's authentication layer, we'll also have to renew session whenever there is a logout or login event happens, and for the same user, that could be multiple sessions on different devices. And in that case, we want to sync that data back on the same UI, right? Right. So let's go back to the Hasura Cloud demo, and let's look at how the GraphQL APIs are being generated from scratch. So I'm going to create a new project. I'm going to name this offline first, and I'm going to create this. Give it a few seconds for it to initialize, and we can see that the GraphQL API has been generated over here, and soon we'll get like a console UI that we can use to create tables and whatnot. Right, so this is currently on the US West region, and we can see that the project has been created. So let's click on Launch Console. So what I'm going to do is I've created a Hasura Cloud project, and I'm going to make use of the data tab to create a new DB. So Hasura lets you connect existing DBs or create a new Heroku database on the fly on this UI, right? So I'm going to create a new database on Heroku and then connect it to this instance of Hasura. So this is getting connected to Hasura now. So Heroku has a free Postgres add-on that we can use to make use of this quick demo. Right. So once this database URL is connected, we've added the data source over here, and we can see the schema listed on the left. And I'm going to create a table called to-dos with the schema that we wanted to create. So let's go back to the schema. You can see that we have ID, text is completed, and whatnot. So I'm going to create text. This would be of type text. And I'm going to create is completed, which would be of type bool. And we have a couple of timestamps, so just created at and updated at, and finally the user ID, right? So I'm going to create created at timestamp, and I can give a default value as well, and an updated at, which would be another timestamp. And in fact, I'm going to remove the default value because The created at value could be different by the time it hits the database, whereas on the client it could have been created very earlier due to the offline nature of the app, right? So I'm going to remove the default value for this. And finally, I'm going to give the user ID, which will be a text type because it's a not zero ID that will come up. I'm going to use the primary key ID and then leave the other columns. I'm going to add this table. So we've created the table successfully. We've got these columns and whatnot, right? Let's go to the API layer and then check this out. I'm going to remove the other queries. So I'm going to make a query called to-dos, which can get the ID and it could get the text and the created at and the updated at columns as well. Obviously, this is going to be giving an empty response. So what we can do is we can do a mutation now to insert to-do, insert to-dos. So I'm going to do an insert to-dos objects, and I can insert the text, which is first to-do from PWA conf, and we can do updated at, which can be both created at and updated at, right? So we can do timestamps for them, which will be both updated at and created at being now. And finally, we can return the affected rows as well. And for user ID, let's say my odd zero ID is odd 01 for now. We can update it later as well. I think this should be enough. Okay, there's a missing field which is completed, so I'm going to give the value of is completed for the to-do being false, and we have created at, which is now. So I've inserted this row and we've got the rows affected as 1. Let's make the other query, which is the to-dos query, and now get back the data from the client on the graphical client. So we can see the ID being 2, the first to-do from PWA conf, and the created and updated timestamps, right? So so going back to our example, we can use so we've used a GraphQL query over here with var clauses and limits and order by. We can technically do that over here to just quickly see as a demo. We can have a limit over here, which would be 5, and there's a var clause. We can say ID is greater than, let's say, 1 for now, and we can add filters and sorting parameters, right? So I'll do an order by, which says ID descending to get the latest values at the top. And let's go to the data tab and actually insert some rows. Let's say this is the second to do, completed is false, and I'm going to give the default values again, and out 0, 1, same user. This is inserted. Now let's make another query. And we've got second to do and the first to do data coming in as well. I'm going to add a var clause, which will say ID less than equal to 2, and this is going to give just the second to do as well, right? So this is different queries that are being generated, and this is all automatically generated once we created the table for the to-do table. This is inside Postgres right now. Cool. So we've used a similar structure, similar app for this. We've created a to-do table and then we've made a query like this for this particular app. So let's look at the actual front-end app to see what the demo looks like. And I'm going to make a split screen to open this in 2 different browser sessions. This is the Firefox window. This is a Chrome window. So what I'm going to do is I'm going to actually make a query. I'm going to look at the network tab and see what's happening on both sides. So I'm logging in now initially with my Auth0 account that I've created. Let's say, right, I'll remove this. I'll click on login. So once this is logged in, I'll be able to look at my to-dos, which I've created on this particular URL. And we can see the GraphQL request being sent for getting the data. The GraphQL request will look pretty similar to what we saw in the code, except that the variables are being filled with the actual values over here. And we've gotten an empty response as well, right? So that's the empty response because I've not added any more to-dos than the initial list, right? So I can quickly add one to-do, PWA conf, and we've got it at the end of the to-do list, right? And we've got a GraphQL query being sent, in fact, a bunch of queries being sent to keep it in sync with the DB. Another thing we can check right now is offline mode. So I have the current one at offline, and what I can do is test offline mode, and I can just press enter, and this is an optimistic update that's happening right now. But you can see that the GraphQL request has actually failed because the internet was not available and it's failing, right? Now I'm going to change this offline mode to no throttling, which is online, and you can see that the requests are being successfully processed. We can test this again with a different browser session at the same time. So I'm going to log in on this Firefox instance and see if the syncing happens real time over here, because we've used a live demo which uses subscriptions to keep our data in sync. I'm going to click on don't save, and we have some data over here. Right, so what I'm going to do here is I'm going to go to the network tab and actually add some data over here. Test on Firefox. And if I go to network over here, so there are a couple of queries being made, and we can see the test on Firefox has actually appeared over here. And similarly, I'm going to do another test of the throttling mode, which would be the offline. I can see add one more in offline, and immediately changes to online. And we can see that once we change this to online, we see that the result now is appearing on the Firefox browser session as well. This is because the user is logged in, it's all authenticated, and also because there's a subscription that's running which fetches the data for you automatically. Right, so so this is the demo that I wanted to show quickly. So let's go back to what's pending. Now you might be wondering, like, why GraphQL for this particular demo? So you have different pieces to handle over here. Like on the consumer side, you have all of these mobile apps, web apps, and microservices and whatnot, which consume data. And compute is getting easier, business logic is getting easier to write apps. This could be even your offline first app. So data access is the bottleneck, because you have producers like databases, internal services, or external services which produce a lot of data. Database infrastructure is getting easier, but data access layer, which sits between the consumer and the producer, is getting a lot of time to build and iterate, especially for very complex use cases like offline first apps, right? So GraphQL lets you bridge this by being a unified API layer for a bunch of these producers and for a bunch of these consumers. So mobile apps will have different data requirements, and web apps will have different data requirements. and there are different databases and API services that are being used, and GraphQL unifies all of them together with a single data access layer. Right, so that's the reason why GraphQL would make sense also. And another reason is Hasura, which gives you GraphQL APIs out of the box for a bunch of data sources, so that you don't need to write your own API layer for most of the tasks, right? And which makes the syncing of the app, which is the RxDB app, pretty easy. You have the other option to use CouchDB replication, but then again, in that case, you would have to write a replication API layer, which would sync it with your DB of choice. So here we're using RxDB to store NoSQL data, and then we are making use of Hasura GraphQL API to sync, to fetch data, and to also do a mutation, and then keep the data in sync on different use cases, right? So that's the demo that I wanted to show, and the reasoning behind why GraphQL ties this all together with a unified API layer, right? And in fact, the front end doesn't need to worry about what database is being used at the backend, as long as it's using a GraphQL query to fetch and push data, right? So the mutation and the query is all it matters for the front end. The underlying database that's being used really doesn't matter. So you can actually sync offline data with any database of choice, as long as Hasura supports that through the GraphQL layer, right? So that's the demo that I wanted to show, and I have a couple of resources to show. So we have our learn resources, which will have the tutorial for actually building out this entire app from scratch. So I can quickly show you that as well. So we have this full stack tutorial with RxDB, which will actually go over step by step on how to build this app from scratch. So you can check this out. This is our learn course. This is all open source. You have the resources on GitHub. You can try out the app, and you have the content on the GitHub as well, right? So that's mostly it from my side. You can try out the cloud project on cloud.hasura.io, create the tables and schema that you require, and then you get a GraphQL API out of the box as well, right? And do check out our docs for getting started, and learn for the RxDB offline first course. It's a simple React app that's initialized with RxDB store and just a couple of GraphQL queries to keep the to-do data in sync, right? So yeah, that's mostly it from my side. Thanks for having me. Cheers.